Good day everyone. I'm going to report chapter 21 about pavement management. In this chapter describes various approaches for pavement management and the data required to evaluate pavement condition. Problems of highway rehabilitation. So, one major problem of highway rehabilitation is the funds they receive are usually insufficient to adequate repair and rehabilitate every roadway section that deteriorates. Lack of funds often limits timely repair and rehabilitation of transportation facilities, causing a greater problem with more serious pavement defects and higher cost. Next is the gradual deterioration of a pavement occurs due to many factors including variations in climate, drainage, soil condition, and traffic. Approaches to pavement management. Pavement management is used to describe the various strategies that can be used to decide on a pavement restoration and rehabilitation policy. Rehabilitation management strategies include consideration of items such as pavement condition, first cost, annual maintenance, user cost, safety, physical, environmental, and economic constraints. Pavement management is a systematic process for maintaining, upgrading, and operating physical pavement assets in a cost-effective manner. So there are steps for a given pavement section. First is assess present pavement condition. Next is predict future condition. Third is conduct an alternative analysis. And last is select an appropriate rehabilitation strategy. Elements: an inventory and condition database, mathematical models to forecast future pavement condition. Third is procedure for conducting alternative analysis. Fourth is reporting and visualization tools to facilitate the interpretation and display of results. Levels of pavement management. So there are two levels. First is the network level and the project level. So network level is concerned with the entire highway network and all of the pavement sections that comprise the system, while the project level is the attention is directed toward determining the specific maintenance or rehabilitation action needed to preserve a specific element or project that has been selected by the network level process. So this is the framework for total pavement management system. Importance of pavement condition data. So the first step in the process of pavement management is to secure data about the condition of each pavement section in the system. Pavement condition data are used for the following purposes. First is establishing project priorities. Second is establishing options. And third is forecasting performance. So, establishing project priorities. Data on pavement condition are used to establish the relative condition of each pavement and to establish project priorities. While establishing options, data about pavement condition in terms of type, extent, and severity are used to determine which available. Third, which is the forecasting performance. By use of correlations between pavement performance indicators and variables such as traffic loadings, it is possible to predict the likely future condition of any given pavement section. This information is useful for preparing long-range budget estimates of the cost to maintain the highway system. Methods for determining roadway condition. Four characteristics of pavement condition used in evaluating pavement rehabilitation needs are: first is pavement roughness, second is pavement distress, third is pavement deflection, and skid resistance. Pavement roughness, it refers to irregularities in the pavement surface that affects the smoothness of the ride. The serviceability of a roadway was initially defined in ASH2 Road Test, a national pavement research project. Two terms were defined: present serviceability rating or PSR and present serviceability index, which is the PS or PSI. PSR is a number grade given to a pavement section based on the ability of that pavement to serve its intended traffic. So, ang kaning PSR is based ni siya sa observation, mag-grade ni siya which is 0 to 5. Then ang kinadak-an which is in a good condition is 5. Then 0 is the low grade. While the PSI is a value for pavement condition determined as a surrogate for PSR and is based on physical measurements. Equipment for measuring roughness is classified into two basic categories. First is response type. Response type equipment does not measure the actual profile of the road but rather the response of the vehicle to surface roughness. Equipment used includes Maze Ride Meter, Bureau of Public Roads Rough Meter, and Cox Road Meter. Another category is profilometers. It is a device that measures the true profile of the roadway and provide accurate and complete reproductions of the pavement profile. Pavement distress. The term pavement distress refers to the condition of a pavement surface in terms of its general appearance. A perfect pavement is level and has a continuous and unbroken surface. So there are three basic categories of distress, which is fractured, distorted, and disintegrated. So, in distress mode, which is fracture, distortion, and disintegration. In distress manifestation of fracture is cracking and spalling. Then in distortion, which is the permanent deformation and faulting, and disintegration is stripping and revealing and scaling. Distortion. So distortion is usually measured by determining the extent of rotting, and disintegration is measured by the amount of revealing. The survey forms distinguish between bituminous and Portland cement concrete pavement. So, for bituminous pavements, the items observed are corrugations, alligator cracking, revealing, rotting, longitudinal cracking, transverse cracking, and patching. While for Portland cement concrete, the measures are cracking, revealing, joint spalling, faulting, and patching. Pavement Condition Index or PCI. The Pavement Condition Index is a widely used pavement distress index developed by the U.S. Army Corps of Engineers. Types of distress when using PCI are alligator cracking, which is a series of interconnecting cracks that are caused by fatigue, failure of pavement surface under the repeated traffic loadings. Next is the beading, a film of bituminous material on the pavement surface that becomes viscous when warm. It is caused by excessive amount of bituminous material in the asphalt mix. Next is another is block cracking. Interconnected cracks that divide the pavement into rectangular pieces. Next is corrugation. Corrugation is a series of closely spaced ridges and valleys occurring at regular intervals. Pavement structural condition. The structural adequacy of a pavement is measured either by non-destructive means which measure deflection under static or dynamic loadings, or by destructive test which involves removing sections of the pavement and testing this in the laboratory. Skid resistance. It is a data collected to monitor and evaluate the effectiveness of a pavement in preventing or reducing skid-related accidents. So example, in measuring skid resistance, so a 10,000 pounds load is placed on two tires of a lock wheel trailer at a speed of 30 miles per hour. A force of 500 pounds is required to move the device. So determine the skid resistance and the surface type, assuming that 3 dead tires were used. So solution. Skid resistance or SK is equal to 100 times F, which is F is the friction factor. So equals 100 times L over N, which is L is the lateral or frictional force required to cause two surfaces to move tangentially to each other, over N, which is the force perpendicular to the two surfaces, equals 100 times the value of L, which is 5,000 over 10,000, is equal to 50. From figure 12.13, at 30 miles per hour and its skid resistance is equal to 50, the surface type is coarse texture and gritty. Pavement condition prediction. Condition prediction models are essential to the pavement management process at both the network and the project level. In the network level, prediction models forecast the future condition of the network and are the basis of project planning, inspection, scheduling of maintenance, and rehabilitation activities. At the project level, prediction models are used in a specific project lifestyle cost analysis to select the most cost-effective maintenance and rehabilitation strategy. Deterministic models. Many states accumulate pavement distress data for specific roadway sections. As is expected with aging of the pavement, the distress rating will decrease. So, family-based prediction models. This approach is referred to as family-based because different pavement sections are segmented into groups or families in such a manner that all pavement sections in a group or family have similar deterioration trends characteristic. Group selection is based on factors such as pavement rank, traffic volumes, climate, structural strength, and surface types. Multi-regression prediction models, in contrast to family-based prediction models which related an element's condition indexed to a single independent variable. Multiple regression prediction models relate the pavement condition index, or PSI, for a given highway section to several factors that affect deterioration, such as age, usage level, climate and environmental conditions, structural strength, and construction materials. There are two main approaches that have been considered to develop prediction models for pavement, which is the deterministic models and probabilistic models. And two approaches presented develop regression-based prediction, which is the family-based and multiple regression prediction models. So when we say probabilistic models, which is considered to develop prediction models for pavement, is a method which is based on the assumption of the future conditions can be determined from the present state if the probabilities of given outcomes are known. So example, when pavement resurfacing is required. So we need to determine the age when pavement resurfacing is required. So determine the number of years or age before a pavement section belonging to family 2 AEDT is greater than or equal to 10,000 will need to be resurfaced if pavement overlays are necessary when the PCI value falls below 74. Solution: using the model previously developed, determine the age at which the section will reach a PCI of 74 as follows. 74 equals 99.74 minus 3.99 plus 0.12 h squared. Therefore, 0.12 h squared minus 3.99 h plus 25.74, which is the 99.74 minus 74 manang 25.74 equals 0. So, isolve na si Jana to in quadratic equation as follows. So, h equals positive 3.99 minus the square root of 3.99 squared minus 4 0.12 times 25.74, which is the c, over 2 times 0.12, which is based na sa formula sa quadratic equation, which is positive negative b minus the square root of b squared minus 4ac over 2a. So, the age when pavement resurfacing is 8.75 years.